So as always, we start with the quote here. Please pay at least 20 seconds attention to this. Okay, so Black-Scholes-Martin option pricing model is basically will quantify our feelings and communicate our feelings about the value. So what would be the value of an option? We have dealt with that very cursorily in chapter 3. We said that, well, value of an option should be at least equal to its intrinsic value, right? S sub 0 minus X. But then you said, no, actually that is not the issue. Sometimes I showed you last time that, well, that option prices are much larger than intrinsic value. So what are the rest of the values? And these questions kept two people, Fisher-Black and Myron-Scholes, up to a task. That how do we quantify the value? I see that in real life, it is higher than intrinsic value, but why? So they use some nonlinear math to arrive at that. And Fisher-Black was a Goldman Sachs employee and Myron-Scholes was in MIT. So Myron-Scholes was leaving at that point in time, therefore he obtained the Nobel Prize. The other part is that if somebody asks you, what is the most used economic theory in the world, what do you think you'll say? You have gone through lots of economic theory, and then you are going to go for another one that theorizes the value of options. Is Black-Scholes option pricing model used by traders day in and day out? What do you think?
I would say yes.
Yeah, every day, millions of traders using Black-Scholes option pricing model. And like in your financial calculator that you have time value of money and other way to figure out the price of a stock. There are some advanced calculator where you just put in the variables and it does the value for options and they check it out. Okay, so let us find out what that is. Black-Scholes option pricing model will relate the call option price to various variables, and this is the 1997 Nobel Prize that we talked about. Okay, so what we will do here is this. There are various assumptions of the model, and we'll just mention it saliently. I mean, it's not, we are not going to go very quickly, deeply. The risk-free rate, volatility of the log return, no taxes, no dividends, and options are European, not American. So it's applied to European option. And this is this formula. Let me ask you a question here. Suppose ND1 and ND2 are equal to 1. ND1 and ND2 are equal to 1. What do you think will happen in here? It will be C equals S sub 0 minus present value of X. Do you agree?
Yep.
Okay. So what is S sub 0 minus present value of X? Intrinsic value, right?
Mm-hmm.
Right? So you see, intrinsic value comes right out of the Black-Scholes option pricing. So it is a special case. Intrinsic value is a special case when ND1 and ND2 are equal to 1. Make sense?
Mm-hmm.
Okay. So now there is a D1 in here and D2 is here, and through complex mathematics, they found out D1 to be natural log of S sub 0 by X plus R sub C plus sigma squared by 2 times T, and then divided by sigma root T. D2 is a simpler, once you find D1, it is D1 minus sigma root T. All of this formula would be available to you. I mean, you can write it on a formula sheet. So nothing to memorize. You need to be careful about how to apply these to generate the call option price. Now, can somebody count and tell me how many factors are in this call option? There is S sub 0, there is X, there is R sub C, there is sigma, and there is T. So how many altogether?
5.
5. Now, when you did stock valuation in your basic finance course, how many factors were you looking at? Dividend discount model was D sub 1 divided by R sub S minus G. How many factors did you take?
3.
3. And this has 5.
Mm-hmm.
And stock valuation, which you learned and applied lots of times, were much simpler than Black-Scholes option pricing. This is much richer expression of the world. That's why people get really attracted to it, that this is a non-linear expression of call price. Okay, with 5 variables, S sub 0, X, R sub C, sigma, and T. And always remember, R sub C and T should be expressed in years. So if it is 6 months, it should be 0.5. Okay, all right. When you apply this and then you get, there is a digression here. This normal distribution table, you can get the normal distribution because this is the place where you say ND1 and ND2. You have to calculate, after calculating D1 and D2, you have to figure out ND1 and ND2, and this is the table you figure out. So suppose, we'll apply this and use this table, okay? So you'll bear with me. Now, these are the data that we are working with. S sub 0 is 125.94. X is 125. R sub C is 0.0446. T is 0.0959. That is converted to years, and sigma is 0.83. Okay? Now you have to apply the Black-Scholes option pricing model. How do you do this? Solution is right in here. Now, I would like you to be very, very careful to what I say. You put, whenever you solve this, follow this slide very carefully. You put in the variables, all the variables there is, 1, 2, 3, 4, and 5. Okay? Then you have to compute D1, and D1 is ln of S sub 0 over X plus RC, which is 0.0446, plus 0.83, which is sigma, to the power 2. Then that thing is divided by 2 times T, the whole times this part, the whole times T, 0.0959, and then divided by 0.83 root 0.0959. Now, do you have any questions on this so far? But this much I can guarantee. If you just look at it, you understand it, but you cannot do it on your exam unless you put the pen to the paper. I hope you will take that seriously, because this is a sure shot way of earning a very good grade. Can you please make sure that you look at that slide and then go through each step and calculate and see whether you get 0.1743? Would you do that? Please say yes or no.
Yeah.
Yeah, please do. I know you guys are smart, and then you say, yeah, I can handle it, and I'll handle it on my exam right there. Okay, please don't. Okay, you have to put the pen to the paper. Okay, so once you get this D1, it's 0.1743. Then D2 is a simpler one because you got the 1.1743, and then you subtract this sigma root T. You get negative 0.0827. So now is the time that you get this normal distribution number. This is the 0.1743, okay? So we go to the table in here, 0.1743. So first is 0.17. So you say 0.1, right? And then you go to 0.7, which is like 0.5675. The area is 0.5, so 0.5675. Okay? So you put this in here, back in here. We see 0.5675. This is less than 43 is less than 0.5. It had, let's say, 1.176. Then you make it 0.18. Okay. For those of you who had gone through all of you have gone through this part statistics, but those who are very excited about that, how do we find out the area for a negative number? You say 1 minus this number, right? So in normal distribution of 0.08 is 1 minus n 0.08. Are you with me on this? That's the way you do it. You cannot find it from the table negative 0.0827, right? So you say it is 1 minus normal distribution of 0.08. So you find out 0.08 from there. What is 0.08 here? So you go to 0.0 and then you go to 0.8, which is 0.5319, right? 0.5319. And then you put 1 minus 0.5319, you get 0.4681. And the last thing is, once you have D1 and D2, followed by ND1 and ND2, is this. You put in all the steps in here, all the variables in here, and solve for it, it's 13.21. So Black-Scholes says that your call option price should be equal to 13.21. Now I'd like to refer back to the stock price and say, okay, if your stock price comes out to be $23.50, and you look at the market, and the market says it is $24, what are you going to do? Your stock price says, after you apply the formula, dividend discount model formula, that it should be $23.50. Market says it is $24. What are you going to do? Yes? Whenever you apply the formula, which formula you call the true value, and which formula and which one you call market value? Remember always, these guys, Black and Scholes, are trying to approach truth from the logic as well as application of math. So we'll call this, yes, this is the call option price via Black Scholes, but we will also call this to be true value. When we apply DDM to stock valuation, we say that DDM value is the true value. So I gave you two numbers. 23.50 is the DDM value, the fundamental value. The fundamental analysis that you are doing is the true value. But the market says it is $24. What are you going to do? Market overvaluing it or undervaluing it?
Undervaluing.
One more time. $23.50 is the true value. Market says it is $24.
Market is overvaluing.
David, do you agree with Liz?
Well, the market's currently 24, so 23.5 is under it. So wouldn't it be undervaluing?
No. Market has its own metric, right? Some way it gets a number, correct?
Right.
And their model says $24. But the true value is $23.50. Why do we call this true value, the DDM value, or any kind of value, bond value? Why do we call this true value? You say that we applied logic, we applied mathematics, and we are arriving at a number. It is dispassionate number, it's an objective number. So objectively, we are getting a value called 2350. And we claim that should be the true value.
Oh, all right.
Right? So let's say you go and try to buy a car. You do your own analysis, your homemade analysis, logic and math and everything. And you say that this car should be $30,000. And you see that the market is saying it should be $32,000. Will you agree with it?
No.
No, because you have your own logic, right? You are getting a dispassionate number, an objective number, right?
Correct.
You get the data and you do it. And then that's the way the decisions are made. Some people will buy it, some people won't. Maybe this is a racing car kind of thing. If you are into it, you will buy it. Even though your things are, say, $30,000. So that's the way market works. People have their own vision of the value and they look at the market. If they see that, well, their vision value is less than the market value, they say, no, I am not going to buy it. All right, makes sense?
Yes.
Okay, So now come to the option. That's where we are at. I just am trying to connect the stock versus option. In call option, it says $13.21. In CBOE, it says $13 even. Which is the true value, which is the market value? Black-Scholes says $13.21. And market says, market meaning CBOE, saying it is $13 even. Which one is true value? Which one is the market value?
The true value would be the 13.21.
Very, very good.
And then market value would be 13.
13. What are you going to do?
You are going to buy a put since it's
This is call option we're talking about.
sell the call.
You sell the call. Your true value is 13.21.
So you buy the call.
Buy the call. Buy the call.
Right.
Yeah. Right? Why? Because market is undervaluing it or overvaluing it?
Undervaluing.
Undervaluing it, right? And when I say what is the most used economic theory, I mean that this Black-Scholes option pricing model is the most used one. Traders need some assistance, a value to look at. Okay? So now, with that thing given, we then say, what are the 5 variables we talked about, right? S sub 0, X, S sub R, sigma, and T. By the way, I lost all my annotation and it was not opening it up. I'll show you there after this is done. So I would like to talk about, okay. You see, I'm going to first check the relationship of call option price that we had seen before, 13.21. How is it related to underlying stock? This relationship that I'm exploring has a name called delta. All right? So when the underlying stock goes up, call option price goes up. That's the delta. So if delta is, let's say, 0.5, you have already submitted a option page in one of the assignments. You say that, well, for $1 increase in stock, call option price will go up by 50 cents. Do you recall that assignment? That you had to interpret delta for me? Okay, so this is with the relationship with stock. And what is the relationship between a strike price and call option? Answer is inverse. Okay, so if you get an option that is higher in strike price, then you pay less premium because your benefits are smaller. Folks, are you with me on this?
Yes, I follow.
Okay, all right. Then the third variable, RC and C. So if interest rate goes up, call option price goes up. This is called rho. Now, I gave you an example. I said that, well, how many ways you can get a stock in future? Let's say I'm talking about stock options. One is that I can buy a call option now. The other one is I can buy the stock now and take it to the future. Okay? So if the interest rates are going up, buying a stock is more expensive or less expensive now?
Um,
You
I
have to
guess maybe the stock would be less expensive.
no one
Oh, wait,
more
wait.
Kevin. I mean, if you have to, you will buy that stock by borrowing, and the borrowing costs are higher now.
Okay.
Will you be discouraged to buy the stock and take it to the future?
Yeah.
Okay, so the demand for borrowing and buying will be less, and the demand for buying an option will be
Higher.
higher. So you see, as RC goes up, demand for call option goes up, therefore it goes up. And that is known as rho. Then comes the second last one, sigma and C. Volatility, as I expressed in chapter 3, is the lifeblood of call option or put option, any one of them. So when the volatility goes up, call option goes up. And this is known as vega. And the last, but not the least, is that time to expiration. When the time to expiration goes up, call option goes up. This is obvious, right? Okay. And this is known as theta. So folks, I mean, I would like to tell you that, and I don't want to talk today on volatility and very important concept of implied volatility. Okay? Implied volatility, not the volatility itself, but what is implied. So we would stop the lecture now and see whether you have any questions on the things that we did. How to calculate call option using Black-Scholes, and what is the relationship between 5 variables and call options. Any questions that I can clarify more?
Nothing for me at the moment, Professor.
Okay. Anyone else? But one thing that cannot be substituted is doing the problems. Okay, start with the problems that are expressed here. Okay, so a general question for you: how do you feel so far? We have done chapter 3 and most of chapter 5. How do you feel about options?
For me personally, I mean, towards the end of the futures part of the class, I felt a lot more comfortable with it. So diving into options, more of the language became more familiar with me.
Mm-hmm.
So feeling pretty good about it.
Okay. And so we had talked about call option, nothing about put option though, so far.
Yeah.
Can you suggest me a way where I can get the put option from call option?
When you do that in the one of the variables,
I know you guys are thinking right at this point. I can feel it even across from electronics barrier. That have you been introduced to some kind of parity before that you can use of? use for this. Okay, I got the call option. Now, based on call option, I'll derive the put option.
Yeah, the put call parity.
There you go. There you go. On the left-hand side, there is long stop and long put. On the right-hand side, it is the long bond and long call, right?
Yeah.
So you can solve put option
Mm-hmm.
from there using the call option price that you obtained, 1321 that you obtained. So basically, even though we do not directly solve for put option, Black-Scholes option pricing model together with put call parity allows us to solve for put option price. Okay. So anyone else would like to say something? Any remark? Hmm? Folks, do you think this is doable?
Mm-hmm. Yes.
Liz?
Yeah, I think it's doable.
Okay. Yeah.
Isabella said yes in the chat.
Yeah. I'm missing her because Isabella, can you fix your thing? I know you are not, you are still in a car or something.
She said she will hopefully for next week.
Yeah, I see that too.
Okay.
Thank you. Thank you, folks, and enjoy the weekend and please do this. And I think if you had fun with features, you'll have more fun with options.
Professor?
Yeah.
For that example we did with the Black-Scholes model,
Yeah.
how'd you get, like, what do you look at for the step 3? If you can go to slide 11.
So, what's slide number what?
11.
11. Thank you. Yeah. Step 3, right?
Right.
Okay.
So then if step 1 is 0.17, I saw you just use the 0.1. Do you not round there?
Yeah, 0.1 first. Okay, let me go to the table.
The table is above it.
Oh, sorry. Okay, table is above it. Okay, so I need to get 0.1743, right?
Right.
So first thing I get 0.1. Then I get 0.07. So that makes it 0.17. Why did I ignore 43? Because it is less than 5. Less than 50. So that is 0.5675. For the other one, it is 1 minus area of 0.08. So 0.0 means I have to be 0.0 here. And then I go all the way to 8, which is 0.5319, which is eventually you will get 1 minus 0.5319.
Gotcha. Sounds good. Thank you.
Yeah, sure. So folks, enjoy the weekend and have fun with options. And if you have any questions, let me know. By the way, you need to go through this PowerPoint. Please make sure you need to go through the PowerPoint, submit it early so that I can give you some tips and to proceed. Okay? And as a group. And don't forget to submit the Chapter 3 solutions that you participated. Thanks a lot.